There is a significant concern regarding the grounding configuration between the main panel and the subpanel. Specifically, the absence of an isolated grounding conductor creates a potentially hazardous situation. According to Section 250.32 of the National Electrical Code, there should not be a continuous metallic path connecting the neutral and grounding systems between the service panel, which is the main panel in this scenario, and the subpanel. The current setup involves a bare conductor connecting the neutral bars in both the main and subpanels, effectively creating a continuous metallic path. This arrangement can lead to fault currents flowing through the neutral conductor instead of a dedicated grounding conductor, thus bypassing the intended grounding system and increasing the risk of electrical shock or fire. To rectify this issue, several corrective actions are necessary. Firstly, install an isolated grounding conductor. This involves running a separate, insulated conductor from the grounding bar in the main panel where the neutral and grounding are separated to the grounding bar in the subpanel. This dedicated conductor provides a low impedance path for fault currents to return to the source, ensuring that overcurrent protection devices, such as circuit breakers, trip quickly to de-energize the circuit in the event of a fault. Secondly, separate the neutral and grounding bars in the subpanel. The neutral and grounding bars should be physically isolated from each other, ensuring that the neutral conductor is only connected to the neutral bar and the grounding conductors are connected to the grounding bar. This separation prevents the neutral conductor from carrying fault current and forces it to flow through the dedicated grounding conductor. In addition to these core corrective actions, it is also advisable to consider a new service drop. A new service drop involves replacing the existing conductors from the transformer to the main panel with properly sized conductors, selected based on the calculated load and in accordance with the National Electrical Code Table 310.16. This ensures that the conductors are capable of safely carrying the anticipated current without overheating. Furthermore, a new service drop should include the installation of a proper grounding electrode system at the main panel consisting of either a ground rod, ground ring, or connection to a metallic water pipe as specified in Section 250 of the National Electrical Code. It is also crucial to have the electrical work inspected by a qualified electrician and obtain the necessary permits from the local authority. An electrical inspection ensures that the installation complies with all applicable codes and standards, and it helps to identify any potential safety hazards that may have been overlooked. Obtaining a permit is also essential, as it provides a record of the electrical work and ensures that it is performed in accordance with local regulations. It is important to remember that electrical work should only be performed by qualified personnel who are trained and experienced in electrical installations. Improper or unsafe electrical installations can pose serious safety risks, including electrical shock, fire, and equipment damage. The use of aluminum conductors requires careful consideration, particularly when connecting them to copper conductors. Aluminum conductors have a higher coefficient of thermal expansion than copper conductors, which means that they expand and contract more with changes in temperature. This can lead to loose connections over time, which can cause overheating and even fire. To prevent this, it is essential to use connectors that are specifically designed for use with aluminum conductors and to properly torque the connections according to the manufacturer's instructions. Furthermore, it is important to apply an antioxidant compound to the aluminum conductors before making the connections to prevent oxidation, which can also lead to loose connections. The size of the grounding electrode conductor, which connects the grounding electrode to the grounding bar in the main panel, must be sized in accordance with the National Electrical Code Table 250.66, based on the size of the service entrance conductors. The grounding electrode conductor should be made of copper or other corrosion-resistant material and should be securely connected to the grounding electrode and the grounding bar. The grounding electrode itself should be installed in accordance with the National Electrical Code Section 250.52, which specifies the requirements for various types of grounding electrodes, including ground rods, ground rings, and metallic water pipes. The resistance of the grounding electrode system should be no more than 25 ohms, as measured by a ground resistance tester. If the resistance is greater than 25 ohms, an additional grounding electrode should be installed and connected in parallel with the existing electrode. The overcurrent protection devices, such as circuit breakers, should be properly sized to protect the conductors they are serving, in accordance with the National Electrical Code Section 240.4. The circuit breaker should be of the correct type for the panel in which they are installed and should be properly labeled to indicate the circuits they protect. It is also important to ensure that the circuit breakers are in good working condition and that they trip properly when subjected to an overcurrent. The use of extension cords should be minimized, as they can be a fire hazard if they are overloaded or used improperly. If extension cords must be used, they should be of the proper gauge for the load they are serving and should be plugged directly into a receptacle rather than daisy-chained together. Extension cords should not be run under carpets or rugs, as this can cause them to overheat. The location of the main panel and the subpanel should be carefully considered, taking into account factors such as accessibility, environmental conditions, and potential hazards. The panels should be located in a dry, well-ventilated area that is free from obstructions and readily accessible for maintenance and repairs. The panels should also be protected from physical damage, such as from vehicles or equipment. The conductors should be properly supported and secured to prevent them from sagging or coming into contact with other objects. The conductors should also be protected from abrasion and other damage. The use of conduit or other protective raceways is recommended, particularly in areas where the conductors are exposed to physical damage. The wiring methods used should comply with the National Electrical Code Chapter 3, which specifies the requirements for various types of wiring methods, including non-metallic sheath cable, metal-clad cable, and conduit. The type of wiring method used should be appropriate for the application and the environment in which it is installed. The voltage drop in the conductors should be minimized, as excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends that the voltage drop in branch circuits should not exceed 3% and the voltage drop in feeders should not exceed 5%. Voltage drop can be calculated using a variety of formulas, taking into account factors such as the conductor size, the length of the circuit, and the current flowing through the circuit. The use of energy-efficient lighting and appliances can help to reduce the overall electrical load and save energy. Energy-efficient lighting, such as light-emitting diode lamps, uses significantly less energy than traditional incandescent lamps and can last much longer. Energy-efficient appliances, such as refrigerators and washing machines, are designed to use less energy than standard appliances, which can save money on utility bills. The installation of ground fault circuit interrupters in receptacles located in wet or damp locations, such as bathrooms and kitchens, can help to prevent electrical shock. Ground fault circuit interrupters are designed to trip quickly when they detect a ground fault, which is an unintentional electrical path between a hot conductor and ground. This can help to protect people from electrical shock if they come into contact with a live electrical component. The regular inspection and maintenance of the electrical system can help to identify and correct potential problems before they become serious. The electrical system should be inspected at least once a year by a qualified electrician. The inspection should include checking the condition of the wiring, the circuit breakers, the receptacles, and other electrical components. Any damaged or worn component should be replaced promptly. It is also important to keep the electrical panels clean and free from dust and debris. The use of surge protection devices can help to protect sensitive electronic equipment from damage caused by power surges. Surge protection devices are designed to divert excess voltage away from the equipment and into the grounding system. This can help to prevent damage to computers, televisions, and other electronic devices. The installation of smoke detectors and carbon monoxide detectors can help to protect people from fire and carbon monoxide poisoning. Smoke detectors should be installed on every level of the home and in every sleeping area. Carbon monoxide detectors should be installed near sleeping areas and in areas where fuel-burning appliances are used. The batteries in the detectors should be tested regularly and replaced at least once a year. The use of arc fault circuit interrupters can help to prevent electrical fires caused by arc faults. Arc fault circuit interrupters are designed to trip quickly when they detect an arc fault, which is an unintentional electrical discharge between two conductors. This can help to prevent fires caused by damaged or frayed wiring. The National Electrical Code requires the use of arc fault circuit interrupters in certain types of circuits, such as those that serve bedrooms. The proper labeling of electrical panels and circuits can help to prevent confusion and errors when working on the electrical system. The panels should be clearly labeled to indicate the circuits they serve and the amperage of the circuit breakers. The circuits should also be labeled to indicate the location of the receptacles and lighting fixtures they serve. The use of weatherproof enclosures for electrical equipment installed outdoors can help to protect the equipment from the elements. Weatherproof enclosures are designed to prevent moisture from entering the equipment, which can cause corrosion and electrical shorts. The enclosures should be properly sealed and installed in accordance with the manufacturer's instructions. The proper grounding of metal objects that are likely to become energized, such as metal fences and metal building components, can help to prevent electrical shock. These objects should be connected to the grounding system using a grounding conductor of the proper size. The grounding conductor should be securely connected to the object and to the grounding electrode system. The use of qualified and licensed electricians for all electrical work is essential for ensuring the safety and reliability of the electrical system. Qualified electricians have the training and experience necessary to perform electrical work safely and in accordance with the National Electrical Code. Licensed electricians have met the requirements of the local licensing authority and are authorized to perform electrical work in the jurisdiction.